All right, so let's go ahead and get started with this. So we are looking at heat of, we're still looking at heat of formation, heat of reaction in an overall equation. So I'm going to call this Big Mama equation just because it, again, takes care of everything. So the heat of enthalpy of a reaction can be determined by adding together the enthalpies of formation associated with a series of formation reaction. So essentially what that says, or what that tells us, let me grab a color pen that makes sense to me. All right, so we're looking at this. The heat of reaction is going to be the products, or the sum of the products. So you'll have whatever, A plus B minus the sum of the reactants, so C plus D. All right, when we put this into real working situations, what we find out is we can get the overall heat of reaction based off of these individual compounds' heat of formation. And it gives us a nice, clean, easy number to deal with. The other thing that I want you to remember is all of the heat of formations, heat of formation from the table is always 1 mole of the substance. So if our balanced equation says that it has like a coefficient of 3 in front of that number, what are we going to do to the heat of formation? Multiply it by 3. So that coefficient that's in front of it will cause that heat of formation to multiply. So let's look at this in application. So go ahead. We'll look at this first little sample problem. Most of the time when you have a question like this, I will give you a table like this that gives you the information for each one. If I don't give you the table, then you'll have to look it up on the larger table that you have. So let's kind of do this one together. So we have this equation, 2 sodiums plus 2 waters yields sodium hydroxide and H8 hydrogen gas. So we have our Big Mama equation, which is delta H Rx. Delta H of the reaction is equivalent to the sum, and that sigma just represents sum, and I have a little trouble drawing that sometimes. Sum of the products minus sum of the reactants. All right. Now, when you're putting the information in, be careful about how you enter them in. Use parentheses, use orders of operation, all of that, just so that you don't mess up. So we're going to start off some of the products. The products is sodium hydroxide and water. So we have 2 times negative 470 plus 1 times an H2 gas is 0. Anytime you have a naturally occurring element or a naturally occurring compound like H2 or O2 or silver or something like that, the heat of formation is always going to be 0. So there's that, minus the reactants, which is 2 sodiums. Sodium's going to be 0, so we're going to go 2 times 0. And I'm only showing this just so that you can see where the numbers are coming in. When we put it into the calculator, we can calculate both of those as 0 to start off with. And for H2O, we have 2 H2Os, so 2 times negative 286. Because we only have 1 mole of H2. So it's 0. All right. So when you plug this in, and again, we can just report this, both of these as 0. 1 times 0 is 0. 2 times 0 is 0. I just wanted you to see where the information is coming from. So go ahead, solve for the heat of reaction. Negative 996. Yes. No, 286. Sorry, from right here. Yeah, that was my mistake. Sorry, it should be negative 286, not negative 228. It is going to be a negative, though. Let me see what you're doing. This table. All right, so I'm looking at this chemical equation, and then this table is where I'm getting the numbers from. H2O is not 0. H2O is negative 286. H2 is 0 because it's a naturally occurring compound. It's what happens in nature. All right. If you plug it in right, you should get a number like negative 368. What units is this number going to be in? Kilojoules per mole. All right, so we have a negative 368 kilojoules per mole. We'll do a couple more of these, and as you do more of them, it should be easier to enter it in and get that. So let's look at this next one together. It says calculate the delta H for the following reaction, and this time we don't have the information in front of us. So before we start applying the equation, let's look up the information. So look up C2H5OH and tell me what number we get there. Somebody look up O2. Well, we know O2. What's O2's number going to be? 0. All right, so negative 277.6. CO2. Make sure you pay attention to state because some of them. And H2O liquid. 285. I've been doing that all day long, and I write it wrong every time. Negative 285.8. So this time they didn't give us the chart, but we still can get that information from the table. So let's go ahead and apply it. Delta H of the reaction equals the sum of the products. So I'm going to go 2 times negative 393.5 plus 3 times negative 285.8 minus and I'm just showing that I have 1 mole of the C2H5OH. So 1 times negative 277.6 plus 0. All right, So go ahead, solve this one and see what you get. And so when we look at this, we see that in the last one that we have in our packet that we're going to do, we're not solving for heat of reaction this time. We're actually going to be solving for the actual heat of formation of cyclohexane. So this number that we're given right here in the equation, or the problem, is actually the heat of reaction for the overall process of combusting cyclohexane. So the standard enthalpy of combustion for combustion to CO2 and H2O at 25 degrees Celsius of cyclohexane is negative 3,924 kilojoules. Calculate the standard heat of formation for cyclohexane. So if you look up on that chart, you're not going to find C6H12 on that chart anywhere, unless I printed a chart that just happens to have it on there. But most of the time, you're not going to see it on there. But then you can look at the other. We can look up the other three. Yes, sir. Hold on. No. All right. So looking this up, when we set this problem up, we're going to have negative 3,924 kilojoules per mole equals, we can do the sum of the products. So what is carbon dioxide? All right, so it's going to be 6 times negative 393.5 plus CO2 gas, so 6 times, what do we have for CO2? I'm sorry, for H2O, sorry. Negative 285.8. Yes. Minus the reactants. So we can go ahead and put, we have 1x. So I'm setting that up as my cyclohexane plus 0. All right, so y'all see where I get those numbers from. Cyclohexane is our unknown. That's what we're solving for. And 0 is coming from O2 gas, which is 0. So when we solve for this, heat of formation for cyclohexane is what? Negative 285.8, negative 393.5. And realize that 0 plus 1x is just going to be 1x, so that actually kind of disappears in the equation. If it helps you for data entry in your calculator or whatever, we could manipulate the equation just so you can see it. So we're solving for the heat of formation of cyclohexane, so it would be the same as saying 6 times negative 393.5 plus the 6 times negative 285.8 minus a negative 3,924. And because all I did was just flip things, just did a little algebra there to get to that. So we end up with this situation. So you should have got 151.8 kilojoules. What did you get, Marche? That might have been somewhere with one of the heater formations that you put in. You might have put it a little bit different decimal or something like that. That would have been close enough for me to give you credit on it. All right. So using Big Mama equation for this, we should come up with the same answer that we did applying Hess's law to it. So it's our goal equation from yesterday was 1 mole of ethane plus 7/2 moles of oxygen yields 2 moles of carbon dioxide plus 3 moles of H2O. So let's do products, heat of formation of products minus the reactants. So we have 2 moles of CO2, so 2 times, and looking at my table, I have a negative 394 plus 3 moles of H2O, so 3 times, looking up H2O is negative 286 on here, minus our products, and our products were, ethane, so that's a 1 mole, so 1 times negative 84.68 plus O2 gas. So O2 gas is going to be, no matter how much of it we have, it's going to be 0. So 7/2 times 0 is 0. So go ahead, plug that in, and see what answer you get. You'll know if you're right away. So you should get a negative 1561, if not pretty close. Yeah, so that would round to 1561 if you go with 4 sig figs. All right, any questions?